Good afternoon, everybody. So I would first like to thank the team of Exactpro for inviting me to speak today. And as already introduced, my name is Darko Pilav, and I'm from Digital Asset. Today, I'm going to talk to you about why smart contracts are actually the real innovation behind the entire blockchain and the DLT space. For that, I would like to talk to you first about what exactly smart contracts are and a couple of challenges that they are solving. But first, let me begin by introducing or giving a quick overview about digital asset itself. With our smart contracting language, DAML, and the ecosystem around it, we are helping enterprises to build the distributed applications and deploy them where useful on distributed ledgers. Our customer base is quite versatile, and a fair amount of large financial infrastructure providers are amongst them. They are actually moving real-world assets onto distributed platforms. Some of the names or some of the projects that we are involved in are, for example, the one with ASX, where they are replacing their entire clearing and settlement system, CHESS, onto a DAML-based solution. Other names of customers are like HKEX, Broadridge, the UBS, Change Healthcare, and ISDA, amongst others. So now, to talk about why smart contracts are so special, we need to understand first what smart contracts are. And for that, I would like to quickly go through the evolution of record keeping or asset digitization. So it all began, of course, with physical records. Physical records like, for example, bearer instruments like cash, or centralized records like land registries. They were around for millennia, and they solved a foundational problem of defining a common way how to understand who is actually owning what. But of course, the handling of the physical records was very cumbersome. Duplication or a recreation of it created errors, and distribution of it meant moving something physically to one place to another. Of course, all of this changed with the advent of computers, and a large number, almost all of the records have been digitized. All the processes around it became much, much simpler, and the recreation was faultless. You could create backups without any issues. And with the introduction of the internet and computer networks, even the distribution became trivial. So trivial that it actually, in turn, became a problem again. Because if you imagine yourself being the maintainer of a record within such a loose network of computers where everyone is copying the data around, and then you want to update or change some data on that record, these changes are going to percolate only slowly through all those nodes, typically in a multi-step process. So each and every holder of such a copy cannot know at any specific point in time whether their record is current or correct. So in order to be able to work in such a network, you need to have expensive and tedious reconciliation efforts, and even then errors are commonplace, which can in turn lead to even more expensive litigation and dispute resolutions. So this is exactly what the entire blockchain technology is trying to fix. So the approach there is to change the model of where you have one or a few record maintainers and a loose network that is copying data around, to a model where there is actually only one single copy of that data, the golden record, and any change to that record and a change to that data is being executed in an atomic transaction. So this means that the reconciliation efforts are not required, and the entire processing becomes much simpler. So if blockchain is kind of so powerful and solving all these issues, why haven't we seen a more readily adoption in the last couple of years? And there are a couple of reasons for that. I'm going to touch only on a few of them, but one very basic principle is that if you look at the tokens that are saved on such a, let's say, public blockchain, or the records that have been written on paper, conceptually, they are pretty much carrying the same data. They are just saying, they're just a mapping from asset to owner. But this is not what ownership is about, right? You're not buying a piece of land in order to be mentioned in a land registry. You're buying the piece of land so that you can that you have the right to build a house on it, that you can lease it out, that you can split it up or sell it on. So actually, ownership is rather a loosely defined term that is saying this person, this owner of that asset has the following rights. But then again, those rights can also be both executed but traded on individually as well. So, so for example, if you mention holding and owning an equity, which means that you have a vote in the businesses, in the matters of that business, and then you sell on your voting right, just the voting right, are you still the owner, or kind of how is exactly the ownership defined? So this is exactly where smart contracts come in. Smart contracts aim to encode not only the record, not only the data that has been recorded up until now, but also the rights that different parties have in relation to that particular record. And then again, not only the rights, but also the rules that are required to process or exercise those rights. So coming back again to the evolution of asset digitization, this is exactly where the true innovation comes in, because it's something significantly different than has been done up until now. Now, a common trap that is easy to fall in is to assume, okay, just now I have this smart contract, it has captured all the data and all the rights and the rules. Now, I should just run it no matter what is actually written in there. So kind of the code is law approach. And this is very far from the truth. Smart contracts should actually rather capture the existing laws and regulations and the means to enforce them. So one of the reasons why this is the case is that contracts are actually not all that rigid, or they're still open for interpretation. And typically the practical meaning of a law or a contract is determined through practice or through legal cases. So if you assume that you have this inevitable execution of smart contracts like we have seen in the past, you're actually introducing quite a few problems, because let's assume there is a small flaw in that contract. If code is law, then this flaw of the contract is part of that law as well, and is going to be executed no matter what. This is not a theoretical problem. We have seen that towards the end of 2016, where there was an exploit, the DAO exploit, and where a significant amount of value has been siphoned away from their rightful owners. And how this has been resolved is that the majority, the 51+% of participants had to agree together on rolling back all the transactions and making a hard fork. So this is actually not what you want to have in normal use cases. Again, you want to capture the real-world structure of agreements and laws. So this means also that parties that are part of an agreement, that are stakeholders to it, need to have the ability to come together, and just them, not the majority of the network, and decide to change something about the contract that they are in, be it well, just changing or updating it or superseding it or even tearing it up and saying, well, this thing is void. So in the end, what a smart contract needs to do is to transparently capture all the rights and all the obligations, and also define the clear venue of dispute resolution. Because in the end, the happenings on the blockchain are also affecting the real world, and then you will have to have someone that is going to enforce it in the real world as well. So in the end, the smart contracts are actually not removing or not replacing the trust, but they are rather making it explicit and explicitly saying, I am trusting this person and this body to enforce it. And this is exactly how it should be. And if you think through it, by removing the implicit trust and not knowing exactly who you trust to, you can start trusting other parties more strongly. Now, another common problem that we have seen is the one about application portability. So what do I mean by that? Now, the current development experience of distributed applications is somewhat comparable to development of applications on mainframes a couple of decades ago. What do I mean by that is there are no abstractions between layers, between the infrastructure layer, for example, and the language layer. So what it means that is when you're implementing a specific use case, you are defining exactly which infrastructure you want it to run on, and then you're locked into it, no matter what. But now, companies like, for example, Gartner has published a study that by 2021, about 90% of existing blockchain implementations are going to be obsolete and are going to need replacement. This is just insane. So how can a serious enterprise invest a significant amount of money to replace a core system onto such a infrastructure if there is a reasonable chance that it's going to be obsolete in mere 2 years? So this is where we as the distributed application development community need to define very clean very clean abstractions between the layers. And this is what we have done with DAML. So with that, you are allowing the development of a specific use case without ever having to think about the concrete infrastructure that you run. You're just thinking about the workflows that you are involved in. And then you can start deploying, for example, on something like a centralized database like PostgreSQL or Amazon Aurora. And then when you see that you need those properties that you get out of a distributed ledger, you can switch over to it. Ideally, it would be just a lift and shift without having to touch anything on the use case. Now, this also brings another quite interesting benefit, because if at the moment of development you don't need to think about or interact with the underlying platform, you are just thinking about the workflow itself. But we have analyzed various implementations of various solutions, and what we have seen is that a significant amount of code, we saw something about 80 to 90% of the code, has been dealing with the underlying infrastructure and piping things around and defining which hashing algorithm am I using, etc., etc. This all falls away. So you are experiencing a significant improvement in development efficiency. And we have received exactly that feedback from some of our development partners who are implementing their own use case on different platforms and different languages. And they came back to us and said that the team working with DAML, because they had to focus only on the workflows themselves, experienced somewhat of a efficiency boost of something like a factor 8 to factor 12, which is, even for me, hard to grasp. So, I've presented now a couple of issues that the DLT space and the blockchains are facing, and quite a few of them can actually be tackled and improved by using a good implementation of a smart contracting language. And this is what, in our opinion, DAML is. So just kind of to summarize what the properties would be is, you want to have a concise languages that captures both records as well as rights and the rules how to enforce them. Then you want to have a clear delineation of rights, which means you know exactly which person can do what. This means the trust assumptions are very explicit, which again in turn means you know exactly who you need to reach out to in order to change anything about that particular contract, to update it or whatever needs changing. Then again, because you know exactly who are the stakeholders, because this is so extremely explicit, the underlying infrastructure can use that information to make sure that only the relevant parties are actually getting access to the data, which allows for maximal privacy. And then again, as mentioned before, knowing who you are dealing with and who is guaranteeing which actions defines explicit trust. And then finally, the last point that I mentioned in the slide is about infrastructure abstraction, being completely independent from the underlying infrastructure, and through that providing the ability to companies for future-proof application development. Thank you very much.